Hi viewers, welcome to my tech video blog. Today I am going to explain you all about my quadcopter build and the components which I have used for building it. So the basic thing which we need for a quadcopter is the frame. I here used F450 airframe which has a built-in power distribution board. So the lower body panel has the inbuilt power distribution. So I will be explaining you about that later. And these are the 4 landing gears which I have bought separately and fitted to this airframe. And we need 4 brushless motors. So here I have used 1000 kilowatt brushless motor. And these are the 4 propellers, 2 clockwise and 2 counterclockwise propellers with their holding screws and nuts. And we need ECS for controlling these motors. So here I have used Simon 30 amps ECS. And then for controlling our quadcopter, we need a transmitter receiver. So this is RCV6i 6-channel receiver, and we have a 6-channel transmitter for controlling this quadcopter. And this is the 11.1 volt 3300 milliamp lithium polymer battery pack which has 35C rating. So this is the basic materials which are needed, the components which are needed for building a quadcopter. So now let's move on to the flight controller. This flight controller is the main part for this quadcopter. So all these motors are controlled via this flight controller. So all the inputs which we are giving through the transmitter is being received by this receiver and sent to this flight controller, and based on those inputs the flight controller is going to control all the 4 motors accordingly. And other components which you are seeing here are all related to the flight controller. So I will be explaining about the flight controller and the components which needed for them one by one. So this is the Pixhawk flight controller version 2.4.8 with the anti-vibration kit. So what you are seeing below is the anti-vibration kit. So that's used for mitigating the vibration errors which will be introduced when the when the quadcopter is flying up in a high speed. So, and also I have used a sponge here, so which acts as a cushion, which is basically for elevating the flight control a little bit up higher, as well as for good damping too. And this is the power module, which is connected to the power distribution board, and another part is connected to the battery. So from battery, this goes to this module. This module powers up the Pixhawk controller, which gives about 4.8 to 5.2 volt, and then it also powers the distribution board, which in turn powers all the 4 ECS. The 4 ECS, as you can see here, has been soldered to the power distribution board within the frame. And this is the U-Blox 7M GPS with the inbuilt compass. So this one is basically used for the autonomous flight, which also I will be explaining in the later videos. This is the buzzer, and this is the arming switch, which is the most important component for this Pixhawk controller. Without arming this arming switch, the Pixhawk controller is not going to arm. And the buzzer is used for different types of warning signals, as well as there is an LED in the main controller, but we have connected an external LED and the USB module so that we don't need to always touch the main controller here. We can plug in the USB and then we can connect it directly to our computer via this module. So here you can see a PPM encoder which is being connected to the 6-channel receiver. So all the 6 channels from our receiver are connected to this PPM encoder, and then the PPM encoder input has been given to the RC in of this Pixhawk. Also, all the 4 ECS are connected to the main out of this Pixhawk controller. So based on the input which we are going to give in the transmitter, 6-channel transmitter, this PPM encoder will be sending the signals to this Pixhawk, which in turn will do some calculations, and this Pixhawk controller is going to control all the 4 motors via this main out. So all these 4 motors and the ECS are connected to this main out. And you can see here there is a 433 MHz telemetry kit. This one comes with a pair. One we can connect to this flight quadcopter and the other one to the ground station. So basically I am using my laptop as a ground station, which I have installed mission planner, so that's been connected to that. This is just an intro video of my quad build. So in the future coming videos I will be explaining in detail about all the other components and the uses, as well as I will be giving you a live demo connecting to the mission planner, as well as showing an autonomous flight. So now I will just power on this quadcopter and just show how it's going to work. So this means that the system is booting up, and once it starts glowing green, that means that it has acquired a GPS lock. So it's still loading up the system and still it's not got an GPS lock. So you can see the arming switch here, it's blinking. So once we press this for 2 seconds, if it glows a steady red light, that means that it's ready for arming. Then you can arm it via your transmitter. So now you can see a green light is blinking up. This means that this flight controller is ready to get armed. So I'm going to switch it off. And the telemetry kit is blinking up. That means it's not paired with the receiver, because I didn't connect the other pair of this telemetry with my laptop, which is acting as a ground controller. So this is just an intro section showing up my basic quad build. Thanks. I will be following up with a few other videos which I will be explaining in detail about the components and how to set up this particular quadcopter and how the wiring is being done. I will be explaining you about all these things in the separate video session. Thank you.